guys, welcome to tutorial 2 under Supernode approach, and we are going to use the nodal analysis method to calculate what the current through the 1/6 ohms, that is the I naught, to calculate the current through this resistor 1/6 using the node voltage method. So we first of all have to identify the nodes that we have. We have how many nodes? We have 4. So we have to assign our node voltages. So we have V1 here, V2 here, and what? V3, and this is what our reference, V4. So our reference is said to be our reference node as usual, which is what? Which is 0 volts. So we are now going to write KCL at the non-reference node. But we've seen that there is a voltage source connected between node what? V1 and V2. There is a voltage source connected between V1 and V2. So it means we have to use what? The supernode approach here. Because we have a voltage between two non-reference nodes. By this diagram, we don't have any elements connected in parallel with this voltage. This 2 amperes is not in parallel with this one. It is across this whole element. So this 2 is not parallel with this one. So we are going to just enclose this portion here. Enclose this portion here and consider these 2 nodes as what? A single node. Don't forget there is another node which is V3, but that one is not part of the supernode. So if you are writing a KCL, we are going to write KCL at the supernode, then later write KCL at what? This node. Okay, so let's write first KCL at supernode. So KCL at supernode. Let's assign our current. We have to assign current to this branch. Let's say I1. There should be a current here. Let's say what? I2. There's already a current here and a current there. And the current on this branch is what? I0. So KCL at supernode. Looking at this supernode, we can see that I0 is what? Leaving. This supernode is between what? V1 and V2. So any current entering or leaving V1 or V2 is part of the supernode. So I0 is leaving the supernode, looking at the direction. I1 is also what? Leaving. I2 is also what? Leaving the supernode. 2 amperes is also what? Leaving that supernode. We are not going to include what? The 4 amperes because it is not connected to where the supernode is. So KCL at the supernode becomes what? I0 leaving plus I1 leaving plus I2 leaving plus 2 amperes leaving, giving us 0. Sum of current entering is 0 is equal to the sum of current leaving. So we have this. Now we have to express each of the currents in terms of the node voltages. So I0 becomes what? V1 minus the reference over the resistor. So we have V1 over the resistor is what? 1/6. Plus what is I1? I12 is V2 over 1/5 plus I2. I2 is V2 minus V3 over 1/3 is equal to what? Minus 2. So we can substitute or we can do our expansion here. The reciprocal of this one, we have 6 V1 plus, so 6 V1 plus what? 5 V2 plus 3 V2 minus 3 V3 is equal to what? Minus 2. Alright, we just expand this portion and we have this. So let's group our like terms. What do we have here? We have 6 V1 V2 plus 8 V2 minus 3 V3 is equal to what? Minus 2. So that's our first equation. We have to write what? KCL at the other node, which is what? V3. So KCL at node 3. So at node 3, what do we have? We have I2 entering, 2 amperes entering, 4 amperes entering. So we have I2 plus 2 plus 4 giving us what? 0. So I2 is giving us what? Minus 6. So what is I2 in terms of node voltages? I2 is what? V2 minus V3 over 1 over 3, giving us what? Minus 6. I2. V2 minus V3 over 1 over 3 is equal to minus 6. So we have 3V2 minus 3V3 is equal to minus 6. So we can divide through by 3. And we have V2 minus V3 is equal to what? Minus 2 as what? Our second equation. Just divided through by what? 3. So V2 minus V3 is equal to minus 2 as our second equation. So now how many equations do we have? We have 2. How many variables? 3. So we can't solve this. We have to bring in another equation, which is the KVL at where the supernode occurred. And the supernode occurred at this portion. So we are going to write KVL in this loop 1. Okay, so we are going to sum the voltages in that loop. That is this voltage, the voltage here, and the voltage here. So we know the voltage across this element is the same as the V1. The voltage across this element is what? The V2. So we have plus minus because the current is coming down. Plus minus, the current I1 is coming down. So KVL in loop 1. Let's start from the 10 volts. We have negative 10. We have negative what? V2. Then we have positive V1 giving us 0. We have V1 minus V2 is equal to 10 as our third equation. So from here we can use the calculator to calculate for what? The voltages V1, V2 and V3. So our first equation we have 6, 8 minus 3 minus 2. And our second equation we have V1 to be 0, V2 to be 1, minus 1, minus 2. In our third equation we have V1 to be 1, minus 1, 0, and what? 10. So our values are V1 equals 54 on 11, V2 equals minus 56 on 11 volts, then V3 is equal to minus 34 on 11 volts. So these are our node voltages. But the question is asking us to find current I0. They can also ask you to find current in all the resistors. But let's focus on only what? The I0. So we know that I0 from our equation, I0 is what? V1 over 1 over 6, which is the same as what? 6 V1. So I0 is 6 V1, which is 6 times, what is V1? 54 on 11. And that one is giving us, so we have 6 times 54 on 11, which is equal to what? 29.455 amperes. Or 454545 amperes. So the current flowing through what? The 1 over 6 ohms is equal to the 29.455 amperes using the supernode approach. You can as well calculate what? I1, which is going to be 5 V2. You can calculate I2, which is what? 3 V2 minus 3 V3. So that's the end of today's tutorial. Thank you very much for watching this video.